Welcome back to Homework Help with Jen, Chapter 4, Problem 55. It says, what mass of sodium chromate is required to precipitate all of the silver ions from 75 milliliters of a 0.1 molar solution of silver nitrate? Right, now the first thing we need to do, this is a reaction stoichiometry problem. The first thing that we need to do is we need to come up with a balanced equation. All right, so let's come over to our paper here where we can work, and we would say that we're starting with sodium chromate, Na2CrO4, and it says what mass? All right, so for some reason this is currently solid, we'll say. All right, plus precipitate all the ions. So we have a solution of AgNO3 aqueous. When we say we want to precipitate out the silver ions, it's because we want to hook up the silver with the chromate, and that's how we'll precipitate them out. So chromate is 2 minus and silver is 1 plus, so that becomes Ag2CrO4 solid plus sodium nitrate aqueous. Okay, so that's what the reaction is going to be. And now what we need to do is we need to balance it. Since we have 2 silvers here, we need 2 silvers in the beginning. 1 chromate, but now I have 2 nitrates and 2 sodiums, so I also need a 2 here. All right, balanced equation, that's the first step of the issue here. So I have 75 milliliters of my silver nitrate solution, and it is a 0.1 molar solution. And what I'm wondering is what mass will I need here? Okay, so what I need to do in my steps is I need to find out how many moles of silver nitrate I have and then link this back. And I can do the whole thing in one big stoichiometry by starting with my volume. Okay, and it's going to look like this. I have 75 milliliters of silver nitrate, AgNO3. Okay, now the next step in this is to change this to moles of silver nitrate. And I would do that with the molarity, which tells me that I have 0.1 moles silver nitrate per 1,000 milliliters. Okay, now hopefully you didn't miss that step. It's moles per liter, but this is in milliliters. So since I know that there are 1,000 milliliters in 1 liter, I can just put in 1,000 milliliters instead of 1 liter. So I can just kind of say 1 liter equals, okay, 1,000 milliliters. Okay, so now I'm up to moles of silver nitrate. Okay, now remember in my stoichiometry, after I get to moles of my known, I need a mole ratio, okay, based on this. So I'd say, well, 2 moles of silver nitrate to 1 mole of sodium chromate. Okay. And now the next step in a basic stoichiometry is a molar mass. So 1 mole of sodium chromate, sorry, that L in moles goes right there. Okay, 1 mole of sodium chromate. So that's what I need next, is I need a molar mass. And I didn't already do it, so I know that I need 2 times sodium, which is 22.99, okay, plus 1 chromium. Where's the chromium? Oh, it always takes me a minute to find this. There it is, number 24, 51.996. So plus 51.996 equals, and now I have 4 oxygens, so plus 4 times 15.999 equals, okay, for a grand total of 161.972 grams per mole. There, so I can do the whole thing in one long step. Okay, so now I work through the math and I say, okay, I have 75 milliliters times 0.1 divided by 1,000, okay, divided by 2 times 161.972. And that tells me that, if I look at my calculator, 0.607395, I can only have 3 significant figures, so this becomes 0.607 grams of sodium chromate. Voila.